An airplane plans to fly due north. On the day, there is a strong wind blowing from the west at a speed of 200 kilometers per hour. The airplane's airspeed is 900 kilometers per hour. In what direction should the airplane's nose point so that it can fly due north? What is the airplane's ground speed? So, if you think about this, the airplane wants to fly due north. And this will be the airplane's velocity relative to the ground. So the airplanes, from the ground, if you're looking up, the plane should be moving this way at straight due north at this velocity v. And this is the scenario we want, since if it wants to fly due north, it must be flying north relative to the Earth. So the airplane has to fly straight north relative to the Earth. And it also says that there is a strong wind blowing from the west. So if this is the north, if that's north, then this direction is west. So this will be the wind, and I'm going to say that this is the velocity of the air with respect to the earth or the ground. And this is simply the wind speed. It's like saying if you're standing on the ground, the air will be moving at this velocity relative to you, since you're not moving on the ground. And this is going to be blowing from the west, so it's going to be pointing towards the east. And this vector here is going to be our plane's airspeed. So this is the velocity of the plane relative to the air. So this is, if you have an observer on the air, this is what the plane's velocity is going to be looking like. So this, if you notice, actually makes a right triangle. And this is the angle theta that we have to calculate. And this is the direction that the airplane's nose should point so that it won't be blown away from due north. So, from trigonometry, we can say that the sine of this angle theta is going to be equal to the magnitude of the velocity of the air with respect to the ground. So the wind speed, the wind, or the speed of the wind blowing from the west, divided by the magnitude of the velocity of the plane with respect to the air. And this is simply the plane's airspeed, which is, I'm pretty sure, is measured by the wind flowing through the airplane. So the airplane speed is measured from the air. And this is equal to 200 kilometers an hour, the wind speed, over the 900 kilometer per hour airspeed, which evaluates to 2/9. So all we need to do to find the angle theta is to take the inverse sine of this value 2/9 here. And that should give you about 12.8 degrees. So theta will be about 12.8 degrees. So to prevent your airplane from drifting too far to the east, you need to point your nose 12.8 degrees. And this will be west of north, since you're pointing 12.8 degrees towards the west of due north. And next, it asks us for the airplane's ground speed. So if you look at this makes a right triangle, which means that we can use the Pythagorean theorem, which says that a squared plus b squared equals c squared. And c is the hypotenuse here. So this simply says that the velocity of the plane relative to the ground squared plus the velocity of the air relative to the ground squared must be equal to the velocity of the plane relative to the air squared. Again, this is ground speed. This part is ground speed. This is the speed of the wind, and this is the airplane's airspeed. So I'm gonna make some more space and rewrite it up here. So the ground speed squared plus the wind speed squared must equal the airspeed squared. And now from there, we just need to rearrange to solve for the plane's ground speed. This will give us the magnitude of the plane's ground speed. So the plane's ground speed is equal to the square root of the plane's airspeed squared minus the speed of the wind. Speed of the wind squared. And now we just need to plug in our values. So this becomes the square root of the airspeed, which is 900 kilometers per hour squared, minus the wind speed, which is 200 kilometers an hour squared. And this gives us about 877 kilometers per hour. So the airplane's ground speed, or the velocity of the plane relative to the ground, is equal to 877 kilometers per hour. And that is how you would solve this problem here.